Okay, well, welcome everybody to the panel discussion as part of the Switch Energy case competition this year. We've got a really great panel, and I think it should be an interesting discussion. So we've got with us today Professor Wen Song, who's an assistant professor in the Hildebrand Department of Petroleum and Geosystems Engineering at UT Austin. We have Professor Silviu Levescu, who's an associate professor also in petroleum and engineering at UT Austin. Dr. Helge Halderson, who's works for Switch now, but has spent a career in oil and gas with Equinor, I believe, most recently, and has a lot of good perspectives. Actually, is an alumnus of the petroleum engineering program at UT. And finally, we have Silvia Pizzigoni, who's joining us from Italy. She is an engineer with Petrovalves over there. So welcome to all of you. My name is Hugh Daigle. I'm an associate professor at UT Austin in petroleum engineering, and I'll be moderating the discussion today. So first, what we're going to do is we're going to go around the table, so to speak, or around the Zoom pile here, and let everybody talk for a few minutes about their perspective on the energy transition and energy poverty, and what we're going to be able to do to supply the world's energy demands for the next 30 to 50 years and beyond that. Wen, I'd like to invite you to go first.
Great, thanks. Yeah, so I guess my research group thinks a lot about kind of taking the existing knowledge base that we've built up from subsurface engineering, and then how do we leverage that towards understanding and addressing some of the problems that we have in terms of climate, and deploying decarbonization technologies, right? So I guess in terms of energy poverty, I guess my perspective would be that the countries who need the energy the most, the most underdeveloped countries, they really need to just use whatever energy resources that they can in an affordable way to get their country kind of up to speed in terms of standard of living. And so then the onus is on the more developed countries like us in the United States to really decarbonize at a large scale. And I think a key component of that is CO2 capture and storage. So that's something that my group thinks a lot about. And then the other component is, these decarbonization technologies that I talked about. So for example, the deployment of wind energy and wind turbines, and the deployment of, solar panels for electricity generation, large-scale grid storage for electricity, and also the electrification of our vehicle fleet. And so with all of these transitions that we're making in our energy infrastructure, we're going to be needing massive volumes of material resources. And so these can be minerals, for example. And so that's something that my group also thinks a lot about, is how can we get these materials and where can we get them from, and in what ways can we process them so that we're doing it in the most environmentally benign and responsible way possible. So those are kind of some of the big questions that we try to think about in my group.
Very good, thanks, Wen. Silviu, I'm going to kick it over to you, and you can talk about your background in the service sector in oil and gas, and your perspectives for the future.
All right. Thank you, Hugh. So after Wen's presentation, I'm not going to touch too much on CCUS. About me, a few things. So I spent 12 years in the oil and gas industry with ExxonMobil first, and then as the chief scientist of the pressure pumping product line at Baker Hughes. And then I decided to move to UT to focus on geothermal. And so I can talk at length about what energy transition means to different people, what energy poverty means as well. But what I would like to bring into the discussion is that, as one of the technical directors on the Society of Petroleum Engineers Board of Directors, I do understand how different energy transition is for different people around the world, right? So when we talk about energy transition, we have the perspective of, people from North America or people from Europe or sometimes people from the Middle East. We tend to forget that actually the energy transition means different things for different people around the world. And so just because our world is so diverse and the poverty has different meanings also, I want to make that point very clearly, right? Second point I would like to make is that energy transition by itself is seen as transition from oil and gas. And so different researchers around the world, again, if you read different news outlets, everybody has more predictions about we need to switch completely from oil and gas, or we need to stay in oil and gas, right? And so again, very diverse point of opinions. And so this is not a discussion about or, right? It's a discussion about and, because for the last 100 years, everything you see around you, absolutely everything, including our retirement money, our future of our children, has been built of oil and gas. And oil and gas doesn't mean only gasoline for transportation. It means plastics, it means clothes, it means materials for construction, for roads, for everything you see around you. That everything that our life is built on right now. Transitioning from that, it means that we have to find ways to replace all materials, and when talk a little bit about that, but also we need to find, to redesign our entire world, our financial system, our future, planning, absolutely everything. So the discussion is not actually only about transportation, it's about everything we see with our eyes around us. And talking about geothermal, what I started to talk with, I can show you actually enough data proving that, buildings, for instance, are larger consumers of energy and larger emitters of CO2 emissions than the entire transportation sector. So we are focusing actually our energy today on how we can decarbonize transportation, and we put so much effort into that. All car manufacturers, all policymakers are talking about how we can convert our entire internal combustion engine fleet to electrical vehicles. But we have a lower hanging fruit in front of us, our buildings, right? So how can we actually use geothermal energy directly to decarbonize our buildings? And I'll let that question, I can hopefully answer later, but for now, I think I took my 5 minutes. Thank you, Hugh. And by the way, it's a pleasure to be here with everybody on the panel. Thank you.
All right, thank you, Silvio. Yeah, those are some very interesting points you brought up, and I hope we can come back to a few of them later on. Now I'm going to invite Sylvia to give her statement. I think she has some slides that she can share with us. So let's go ahead and see that.
Okay, good evening, everybody. Do you see my screen?
Yes.
Okay. I have prepared this short presentation about measuring energy poverty and computing index to tackle and measure energy poverty. First of all, why is it important to measure energy poverty? That is the topic of this year's competition. Because measuring provides us the borders, let us know what is the problem, so it helps us to comprehend it, and then it helps us to address action to fight against this problem. Is it possible to measure something like energy poverty? Actually, it's a kind of issue that can be described with the acronym of VUCA, like our reality. So volatile, it's a problem that is volatile, uncertain, it varies over time and place. It's complex, of course, as our world is getting even more complex. It's a multidimensional concept, and also is ambiguous because it's culturally sensitive. Due to this factor, due to these features of energy poverty, it's difficult to measure it, to address it with a single indicator, and also it's difficult to define threshold that can be applied everywhere. Main parameter that should be taken into account when implementing energy poverty index are, of course, availability, access. So is energy available? Accessibility. So even if energy is available, do people have access to it easily? Affordability. People can afford energy. Maybe the energy prices are too high or the cost of supply is too high for their income. And then at the end, sustainability. I'm saying this because the energy poverty index field is not something that is studied and is finished. It's something that we can and we must still research on because measuring is important. So these are the parameters that should be taken into account when someone decides to start a computation for energy poverty index. And methods of measurements can be performed according to expenditure or according to parameters and different metrics, or also according to using direct measurement, for example, the temperature at home. There are different kind of indicators that can be used and aggregated to get an index. There are primary indicators or secondary indicators that do not measure directly the energy poverty, but they are related to it. And the beginning of measurement of the energy poverty concept started in 1991 with a single indicator approach. So at the beginning, there was just the concept of if the energy expenditure in a household is more than 10%, then the household of the household income, then the house is said to be energy poor. So at the beginning, Boardman in 1991 with the first this first kind of abstract, not that much, but kind of first measurement of energy poverty was addressing especially the issue of affordability of energy. Then the other measurements arose in the history. For example, 2004 energy consumption matrix, in which on the x-axis you see the useful energy consumption, and on the y-axis the different share of energy source used. Another interesting measurement for the energy poverty is the energy poverty index 2010. You research from researchers. They address the measurement to two main aspects. One was the inconvenience of the energy mix used in a specific community or place. So basically, they gave a mark to each energy source based on these 7 parameters. So, for example, how is it distance from the house? What is the time spent on energy collection? And then with the mark of each source, they aggregated this data and they provide a mark, a grade to the energy mix used by the household. And the other parameters was instead the lack of sufficient energy to meet basic household needs. So with this simple formula, they compare the actual energy consumption with the threshold energy requirement. And then these 2 factors, so one is the inconvenience and the other one is the lack of energy need. The energy supply, they combine it and they provide the energy poverty index. Other measurements was the multidimensional energy poverty index of 2012. And then many other institutions and researchers investigated on about how to compute in a broad and comprehensive way an index to measure energy poverty. For example, even the International Energy Agency, of course, or World Health Organization, and many others. One of the latest that I've read about is the Composite Energy Poverty Index. They were very proud about this paper because with this index was a bit complex, but with this index they could tackle almost all the features that we have said before. So the availability of energy, the accessibility both of electricity and access to modern cooking system, and also the affordability of the energy. As a conclusion, I wanted to present this small presentation because the world of measurements is interesting, and measuring is important to address problem and to understand better the problem, because even in the problem solving science, let's say, there is a lot of importance is given to the problem and to the measurements, and unless the phenomena can be mastered through calculation, they will remain just something abstract, leading to nervousness and blaming. And my latest advice, to all the people that will listen to this panel, is that if they want to start research or a computation of an energy poverty index, remember the SMART acronym. So the index must be specific, measurable, attainable, relevant, and time bound. Thank you so much. Let me.
Okay, thank you, Sylvia. It's some really good perspective on what we're actually talking about and some good definitions. So thank you for that. Helge, I'd like to invite you to give some thoughts here. I understand you have some slides as well, so we can have a look at those.
I do. Something happened. I got a double bar here in the middle of my PC. So let's see what we can do about that.
See if we can make this work.
Yeah.
Cool.
Let's see. Did you unshare after presenting?
What? I have removed my sharing.
Yeah. Seems to be acting up on me. I have kind of 3 sets of you. And
okay.
Yeah, so thank you very much. So I'm Helge Halldorsen. I finished my PhD at UT in 1982, 40 years ago. And after that, I worked for BP and Exxon and Equinor and lived just about everywhere and enjoyed every day of it. So today we are addressing a very important issue in my book, which is also the case competition for this year, and that's the dual challenge. So framing it in terms of the UN Sustainable Development Goals, you have number 7, affordable and clean energy, and number 13, climate action. So 2.4 billion people, according to the latest from the UN, do not have access to clean cooking. And I thought, how can I illustrate that? So if we put 7.3 USAs next to each other, like you see here, none of them in this 7.3 countries have access to clean cooking. And many do not have access to electricity either. When it comes to the climate, of course, we have indoor and outdoor pollution. And the latest from Lancet is that kills 9 million people per year. And then, of course, you have the climate change, the big picture for the planet. Greenhouse gases went up by 6% in 21, and everyone expects them to keep going up also in 22, even if they should go down by 8% every year for the planet come in under 1.5. So here we see the evolution of global direct primary energy. Mankind started using fire about 125,000 years ago. And then, of course, we added the ones we know in sequence like this, more or less, plus minus, right? But I think you'll agree, we're not talking about energy transition, we're talking about energy addition. And we, in fact, keep using more and more of everything as we go forward. Right now, this is the latest from BP. 82% of the energy comes from oil, gas, and coal. And renewable, which is what we hope will take over the world, adds up to 6.7 if you include everything. And wind and solar are now at 4.6. And here is the emission picture since 1750, almost up to 40 billion tons of CO2. And then, of course, we have the other greenhouse gases on top, and it's still increasing. The developed countries are going down. They've hit their peak and now it's going down. And because of population growth and economic development, Asia is going up massively, as you can see here. And Africa and South America and India still very low compared to anything else. The cumulative emissions since 1750 is 1.5 trillion tons. And we see who has added the most: Europe, Asia, North America, Africa, only 3%. Here is a lady in South Sudan, and I want us to imagine her life, because this is disproportionately hitting women. They spend hours looking for wood to burn, to cook for the family. Look at the fumes hitting her face, and that's the pollution and premature death we talked about. She can't work for an income because she has to do this. She can't go to school, and she has larger families because that often comes along. So imagine that all of us on the panel, we have no energy, no phone, no computer, no TV, no clean water, no nothing. On the water side, you have more than 771 million people that lack safe water, and 1.4 billion do not have access to a toilet, according to water.org. So this is the life of so many people around us. If you look at the world in terms of level of income, the blue is the rich countries, and look how few they are. So it's kind of the OECD countries. So back to the situation again, we must help all we can this lady on the left to go from wood to something better. And LPG is better, even grid from coal is better, all the way to renewable with solar and wind, which is totally emission-free when they are going. And that's ticking off a lot of green good things on the way. Over here, this could be me sitting in Austin with my iPad and telephone. All the rich countries have to support all we can, the developing. It, then we will have clean cooking for all, electricity for all, and that's just 1% of the annual investment in energy between now and 2030. Just think of what we did during COVID. All the countries teamed up, we spent trillions to fix it. This is something we can do if we want to. So to sum up, the dual challenge is to get energy for all and environmental protection. And as we go from fossil fuels to lower emission fluids, that's because we want to come in for the planet below 1.5, but we cannot forget as red for energy poverty and the lives that we have to improve for them. So on an optimistic note, no simple solution. It is solvable, however, if we act as one team, and together we can better the world. Thank you.
Okay, thank you, Helgi. It's a really good food for thought. This is something that I say sometimes, which is for okay, I think I froze there. So here we are. That's good food for thought. I often talk about, I guess this would maybe be the first question. If you think about replacing some of those cooking fuels simply with, LPG or natural gas.
I think you froze a couple of times the way it looked for me. Was that the same for you guys?
Yeah, even me, I
That was-
use it for.
That was yeah. All right, let me start that question again. So if you think about, just simply replacing biomass for cooking with something like, LPG, that's, you know, you're still using a fossil fuel, but that's already a good transition. So, you know, should we be leapfrogging fossil fuels here, or is it, you know, okay to have the progression that we've seen in the developed countries happen?
Hugh, you froze again. We couldn't.
I know I'm having connection problems here. Let me try one more time. We'll see if this sticks. So if we think about transitioning to cleaner fuel sources in developing countries, all right, so first question, what role are fossil fuels going to play in the energy transition going forward? And, you know, especially in terms of improving indoor air quality for replacing biomass as a cooking fuel source. You know, that's a great example where just switching to natural gas would already be a big improvement. So I'd like to hear y'all's thoughts on that.
Yeah, I can start if you want.
Sure. Yeah.
I think that if you look at all the forecasts of the role of fossil fuels going forward, you have BP and Shell, you have Exxon, you have McKinsey, you have IEA, and everybody has kind of a peak and they have scenarios. And the reason they have scenarios is that it depends. It depends on technology and on policy, incentives, consumer behavior, and so on, right? So let's start with coal. That's kind of the black sheep of the fossil fuel family in every camp right now. And if you look at the numbers, coal is, I think, 36% of electricity generated in the world is coming from coal. And mill, you can compute how many you need to substitute them for what coal used to do for you. And it's an enormous number. And then it's back to the metals that Wen talked about, right?
Right.
You have to kind of almost of 100 million is gone, and we're down to about 25 million barrels a day. So I would say the error bar between today and 2050 on oil is 75 million barrels, from 100 to 25, or from 100 to 75. And if you look at natural gas, which is then the base load when wind and solar takes over, it's almost as big an error bar on that one. But coal is the one that people think that we can get down to zero in 2040 if we ramp up quickly enough solar and wind. And I understand we're going to talk about the metals a little later.
Yeah. Okay. Yeah, that's really good points. Does anyone want to add to that?
Yeah, I would like to build a little bit. So excellent comments. I fully agree. And so if I remember the question correctly, it was about biomass versus fossil fuels, right?
Yeah.
And so the point I would like to make is that, you know, currently actually the entire narrative about energy transition is driven by policy mostly. You know, for all of us here who know how you know technology is scaling up and deployment, especially at global scale, is, I mean, nothing happens overnight. It's going to take, you know, years, if not decades, for a meaningful, you know, adoption of new technologies globally. But so the point I would like to make here is that yes, everybody agrees that, you know, we are in some kind of transition. It's more or less technology, or it's more or less policy. It's, you know, all of the above, all that. But at the end of the day, what truly matters is that we need to reduce our emissions, right? I think everybody agrees about that. How we do it, actually, that's where, you know, we don't agree with each other. This is how, you know, the oil and gas industry, we all believe that, you know, our products need to be, they are needed by our society the way it's built. And then, you have other, stakeholders who say, no, actually, we have to get off completely oil and gas, right, or coal. And so I think we are arguing now, and all of us feel we don't have time to show that actually we do clean our air. And so how we do that, actually, that's where we need to talk more about, not actually what energy sources we need, but how can we clean our air. And so I can talk at length about how much the oil and gas industry is doing about that. Unfortunately, the other camp doesn't want to hear any of that, right? So it's more about communication at this point. I think we can, make very important, progress in cleaning our air just by getting all of us in the same room and talking, and stop arguing about who is the true color of the sun. It's really about how actually we care about our planet in the most meaningful way.
Yeah, that's you bring up an important point there, Silvio, which is that, oil and gas, is most of our carbon emissions right now, and it's incumbent on them to try to reduce that. But there's a certain level of distrust out there in, the ability of oil and gas companies to do that. And I think that's an impediment to to making progress for sure. Okay, well, let me throw out the next question here, which is, thinking about the energy transition, is it ever going to end? Are we ever fully going to be transitioned?
So Hugh, if I may, I guess I was muted, but I wanted
I'm
to.
Sorry. Yeah, you want to address the previous question?
Yeah,
Go ahead. Go ahead.
So, I think that kind of bringing it back to the energy poverty discussion that, we're trying to address here. I think it's dangerous for us to kind of bring this one size fits all or one solution fits all kind of approach, right, to decarbonization. Of course, that's what we are all trying to do, but at the same time, basic health and energy availability, right, those are incredibly important for developing nations. And so for those nations, right, they're going to be continuing to be using these fossil fuel resources as an energy resource, whereas kind of in the more developed world, we have other tools that we can afford to use. And so I think a more kind of discretized solution based on which country or which part of the world you're talking about, I think that's incredibly important. And so the role of fossil fuels moving forward is that we're going to be still needing it in these developing nations so that they can have a basic standard of living, as in the rest, in the more developed countries like where we are, we're incredibly privileged to have the economics to be able to deploy our renewable resources. But again, even in this kind of a world, right, these hydrocarbon materials, we're still going to be using them, maybe not as an energy resource, but as basic building blocks for other things.
Yeah, those are all really good points. And I like that comment about there's no one size fits all. It's really a diversity of sources at your disposal. And so that might be a good lead into the next question I had, which is, if you look long term, are we ever going to say, okay, the energy transition is over, we've transitioned? Is that ever going to happen?
No, it's never going to happen. There's always a 2.0.
Yeah.
We didn't stop sailing because we ran out of wind, right? So I think also we can talk about green swans. All of you know the concept of a black swan. That's something that is totally unexpected, right? And in energy, just like we heard from Wen, China with 1.4 billion, India with 1.4 billion, they're using a lot of coal, and that's why they have 2060 and 2070 as the kind of peak in their countries, while Europe and North America and so on will transition quicker. So I think the speed of transition is very different in all the countries. And those who are on the leading edge of technology, they will come up with new and improved things all the time. It's like, oh, iPhone 5, 6, 7, now we have 14, right? And that's going to happen with the way we do energy as well, with batteries and e-fuels. And, you know, the list is so long. And the minute we have done it in the developed countries, we should quickly pass it on, you know, to India and China and developing nations so that they don't have to do the experimentation that we did, right? So then we can help them speed up going from dung and wood to something better, much quicker, because we shared what we did. And then the green swan I talked about, that could come and solve it, most of it for all of us, that would be fusion, of course. We do have fission in the 400 power plants around the world, nuclear power plants, and people don't like them. So we have the not in my backyard problem with nuclear. Even if it is the least emitting and the safest, even if we build in Fukushima and Chernobyl, the number of deaths per megawatt generated is still the lowest, among the lowest for nuclear. But it has a problem. But if we get fusion to go, then we have a green swan that's going to change the whole picture. So bottom line, no, it's never going to be over. Always keep improving how we do it, in my view.
I would like to add, yeah, for example, in Italy, since 1986, we have stopped with nuclear. And about transition, I also believe that we will keep going on with transition, and we have to pay attention to the greenwashing and to the labels like clean energy, because no energy can be no source can be completely clean. So each source may have their own problems that can be, for example, in the case of electricity, can be the material, the rare earths. So we have to use always the approach of life cycle assessment when evaluating the real impact of an energy source.
Yeah, really good comments there. Gwen, Sylvia, do you want to weigh in here?
Yeah, I agree. I don't think the energy transition is going to end. I think it's just a normal evolution depending on, supply and demand. It's as simple as that, right? If we are trying to force it, actually, it's something that we never done in our history as a humankind, right? And that's probably the biggest challenge we have right now, because we push with policy the energy transition based on not on demand necessarily, but based on on some completely new rules, right? And so we are rewriting here the entire laws of economics and supply demand balance and technological progress, everything pretty much. And so it's a very complex problem. It's probably the most complex problem we ever solve as humankind. So so because of that, I don't expect us to have a solution in the near future.
Yeah, I guess, and we're always tempted to think that we're living at the end of history, but it'll keep going. It always does.
Yeah, and I guess I think we as a human race tend to have, we're incredibly innovative, and we're very good at finding resources and ways to get around problems. And so when we first, I think, figured out that we could use coal as an energy resource, right, there was no way for us at that time to anticipate all of these, adverse results that have happened that we now understand, because we hadn't lived through that. We hadn't investigated this thoroughly yet. And same with, oil and gas. And so as we move forward with, these more renewable resources and the infrastructure, right, chances are there's going to be other impacts that we had not anticipated when we set out on this. And so, I'm sure we're going to be transitioning to other, materials or approaches. And so because, as a way to kind of overcome some of those challenges that we haven't, predicted.
Yeah. So, I've heard a lot about, technology development and technology sharing. These are all good ideas. And maybe the next question I have is, so getting back to energy poverty. So what's the best way that developed nations can help developing nations, overcome energy poverty issues and, improve quality of life and that sort of thing? And Sylvia, I might start with you because I think, you spoke to this a little bit in your introduction.
Silvio or Silvia?
Sylvia. Yes, go ahead.
Hugh, you are frozen. Who do you want to start first?
Sylvia, please.
Silvio. All right. Again, I don't think it's an easy problem. I think we all want to help everybody, especially, working for an international company. It was just that, right? We had operations in, globally, and it was an amazing experience actually to go visit and see for yourself. But at the end of the day, to me, is actually a very narrow point of view, right? We are talking about energy poverty. We are talking about energy transition. We are talking about all these global, events, but still we are thinking locally. And at the end of the day, who is going to pay for all these, right? And so just like I heard earlier this comment, I mean, as long as the rich countries don't step up and help, just because it happens somewhere else, it doesn't mean actually it's not affecting everybody, right? We live all on the same planet. And so and not to go to the same stages that the rich countries, went in the history. So accelerate that process. And I think by doing that, I totally agree with Helder here that, probably that's how we are going to reduce our emissions the fastest and afford the energy the most.
Great. Now, Sylvia, would you like to weigh in next?
Well, I may add that the developed nation should of course share their tools and their knowledge about the issue with the developing nation, and a philanthropic support to the developing countries, and of course an economic support. And also I believe that on the instruction side, so the learning side is very, very important, because the youth are the future. So a lot of investment also should be focused on schools and maybe learning programs. That's why also I really estimate what Switch Energy Alliance is doing, because they are sharing knowledge, and this is one of the steps to get a solution together. Also remembering that the approach should be long term, not short term, because this problem is enrooted and must be derooted, and remembering the complex nature of the problem.
Yeah, no, those are all real good points. Helge, do you want to jump in there?
Yeah, I want to start with Scott Tinker, our chairman in Switch. He has put it this way: energy does not eliminate poverty, but poverty cannot be eliminated without energy. So I think we have to put energy on top. That lady I showed, Sanju in South Sudan, she has to get something else than wood and dung to avoid those fumes and killing her and the family, right? So it starts with energy. And if it costs 40 billion per year, we can afford that check, right? We have to avoid corruption and all that stuff, right? But we have to think like during COVID and say, this is unacceptable. We are writing checks for 40 billion a year for 8 years until nobody has it like that. So that's energy. And then there's education. There's no better investment anywhere in the world than education. The NPV of education is enormous, right? Even just a little bit, because then you can get a job, then you have a smaller families, and here we go. So that's number two. And then it is technology and innovation sharing. It's United Nations. It's a different mindset. It's like a global solidarity mindset. We can't sit in a rich nation and just be so happy, right? If somebody is not so happy. So I think the mindset has to be broadened. Like Nelson Mandela, he talks about Ubuntu. Ubuntu is kind of everybody is sitting on a carpet, and if you move, we all move, right? So we're all connected somehow, and we have to get that feeling that we can't be happy when somebody is that unhappy. But these are the 5 things I would put kind of to fix it.
All right. Wen, do you want to offer some thoughts here?
I think I think, Silvio and Sylvia have kind of already discussed what I wanted to say. So I think.
Yeah, I think it's important, the technology sharing in education, I think is a component to this you cannot ignore. So, but we're coming to the top of the hour here, and I know some of our panelists have to depart. So I think this might be a good place to close it out. So I really appreciate everybody's time. This was a really good discussion, and I hope that all of you out there watching this have gotten some good ideas out of this, and thank you all for being part of this.